Hello, everybody. Welcome to another episode of BLS029 Show and Tell with CHAU TRAN in the place. Ciao, good to have you back.
Yep, I guess I don't have to introduce myself.
No, Ciao is a long-time resident. For those of you that don't know it, see one of my other videos and he might be there. Chances are big. Ciao, awesome. Good to have you back.
Thanks for having me.
More than welcome. Always welcome on the stream. Let me double check if we are indeed live. Yes, we are live on YouTube. That's awesome. We have a bit of a special moment because it's the first time Ciao is on my stream being a dad.
Thank you.
Congratulations. About a month ago, I think, maybe 5 weeks, 6 weeks ago.
Five weeks.
Yeah. Brian got born, all healthy and well. Small little boy. And he might at some point be featured at the stream. So awesome. Super nice.
It depends on how his feedings goes. He's eating right now, probably.
Right. Very cool. Yeah, awesome. I think we can dive right in. We don't need any further introductions. Today is going to be about the TypeScript compiler API. You recently launched an updated version of AutoMapper, which we discussed before in the stream. Are these two things related? Is this related to why talking about this today?
Yes. I feel like I learned not quite a bit. I learned enough to be able to share this information with people so they can start building awesome things. Because the TypeScript compiler API actually opens up a lot of possibilities for everyone.
Very cool. Yeah, and one of the things is, for instance, doing stuff like decorators. This is why you need it, right? If you want to build your own decorators, or is this not?
No, this is not. This is not needed for building your own decorators. This is more about. So, this is more relevant to library authors like us, like you and me. We build library that's going to be interact with the consumer's code. However, when the consumers pull in the libraries, they actually just use the code alongside with their code. But if your library somehow has a portion of the API that's gonna utilize the TypeScript compiler API, you can actually alter the consumer's code in a way that it will work with your library, which I can go into. I can explain a little bit more after we go through the demo and the slides, and then we jump into like, why do I talk about it today?
Awesome, super cool. Let's dive right in. We're going to say hello to, and this is Kang Le. It looks like Vietnamese name.
Yep, it is Vietnamese. I share this on my on the Angular Vietnam group.
Awesome, so. Kang, very welcome, and other people as well. And we have another longtime resident, Abel de la Fuente. Yep, we're here. Awesome to see you're here, Abel. Great news for everybody. I'm going to try and commit to a more fixed schedule. So I hope to do BLS every Wednesday at 2 EST. Well, now it's Friday, so I'm already breaking off. Let's keep being flexible as well. I think it's time to look at the presentation. And I would say the screen is all yours, Ciao. Go ahead.
All right. So before we dive into this, just a little bit of a disclaimer. I know the title of the talk or the title of the slides is TypeScript compiler API, but we just like slide right by the TypeScript compiler API, and we would dive into one of the stages of the compilation process by using the compiler API, right? So let's just jump right in. So what is TypeScript compiler API? It is actually a collection of APIs that allows us to handle TypeScript or JavaScript code. This is this is TypeScript compiler API, but you can use this to handle JavaScript code like a TypeScript compiler. This is what the TSC, which is short for TypeScript compiler, is running under the hood. So the TypeScript team actually exposes this collection of APIs for developers to use. So I have some code snippet here, very simple. You import TypeScript. We rarely see somewhat import from TypeScript because it always just a compiler. We write some TypeScript code, and the TSC will like compile our code. We rarely see like we import from TypeScript.
Right.
So to use the API, we will import from TypeScript. And I have some source code here, and you can see clearly this is TypeScript code with the string type annotation.
Yep.
And then we can just use it. We can just use ts.transpile module, and we pass in this source, and we pass in some compiler options. And this object, like the second argument of transpile module, is actually what in your ts config. So it is identical to that. And you can just, so this result will give you, I believe it is a mid result, if I remember correctly. If not, it's just some result. And you can stringify the result. It will give you that compiled JavaScript code. If you want, you can actually just copy this code and run it, which I don't have like set up right now, but you can just run it. Set up like a TypeScript project, and then you can run this code and you can see the output.
Right. So to quickly resume, TypeScript is written in TypeScript, if I understand correctly, and which means it gives us whole access to the same thing.
Yeah, right.
Yeah. So when I see import from TypeScript right away, I generally think this person must have been super desperate to reach out to the heavy tools.
Right. Yep.
But yeah, I think. That's an interesting point to know. So source code that we write ourselves, for instance, in Angular or Nest app or any other TypeScript app, actually at some point gets compiled down to JavaScript, and we can just do the same thing in our own code.
Yep. So again, that's it. This is the compiler API. Like unless we want to create our own compiler using TypeScript compiler, I mean, like you can just have your own language with the TypeScript compiler, to be honest. Right. But really, this is not really interesting. It's very heavy on the low level side of things and not that helpful to us library authors or developers who do like day-to-day job.
Right. So this is interesting for people that build a tool like Angular CLI or something like that, maybe.
That is the Angular compiler, actually.
Yeah. Right.
Or something like that. Or if you want to have like some features that ECMAScript doesn't want to implement, you can just use this to implement yourself.
Awesome. Okay, cool. Yeah, all
right.
Clear. Yeah.
All right. So next, transformer. This is why we're here, people. So transformer is a part of the compiler API, and it is just a function that takes in some code and then returns some code. And I want to mention here that some code is not that source code that we take a look at in the previous slide. Some code here is actually the AST, or the abstract syntax tree, that the TypeScript compiler output.
All right.
And then we can use that AST. We pass this AST into our transformer, and then we can modify or alter this AST in our favor. So imagine you have the consumer's code, like someone else's code, and you can actually modify that code using the AST to do something meaningful to your library. So by definition, this is the most helpful thing that the compiler API provides us. This allows us to actually alter code programmatically.
Very cool. Yeah, and so because it's TypeScript, you have all type completion. So basically, you give it a piece of code, it will come up with a huge tree of objects, and arrays of objects, and you can loop through this like there's no tomorrow. I've looked at it. I think it's super overwhelming because the smallest piece of code gets broken down in all these little parts.
Yes, it is very overwhelming when you first look at it. But this is the purpose of this talk, is to like lowering that like barrier of entry into the AST or the compiler world. So a lot of people have ideas, but they don't know how to implement it. Maybe the compiler API is the answer.
Right. Awesome.
So before we dive into the transformers, a little bit of context about the compilation stages. There are 5 stages. So when like from the moment that TypeScript touches your code, your source code, your TypeScript source code, it will go through all 5 stages. The first stage is scan. So the scanner will scan the source code into tokens, or somebody will know this step as tokenizer. Tokenizer. So basically, like the word function will be scanned into like a token function, or the semicolon, or the quotation mark, the parentheses, that like colon, or that dot 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 in the spread or rest syntax. All of those will be tokenized. Next will be the parse stage. In the parse stage, the parser then parses those tokens into the AST. So actually, the AST is available for us in the compilation process pretty early on, like on the parse.
Yeah.
After the parse, we have the bind. Bind is probably the most difficult stage to actually like interfere. This is the stage where, okay, the binder will look at the AST and will link the references between different nodes. So let's say you have like a class user that depends on some other class. So the binder actually have to link the references like in terms of imports and exports. So the compiled JavaScript code can understand or can actually look for those external modules. So the bind step is pretty, so that's why, so the transformer step is after the bind step. So it makes it even harder for the transformer to actually like import from somewhere else and then use that import code, because at the transformer step, it has already been bound.
Right.
All right. The next step, transform. This is what this talk focuses in and what most developers focus in. So the transformers, as mentioned, allow developers to change the code, usually from the consumers, in any way we want at compilation time. So you know that at compilation time, TypeScript provides a tons of information about your code with the type system. All of that gets stripped away in the runtime, right? So to be able to like write code based on the compilation is helpful.
Right.
The final step is emit. This is to emit the compile code somewhere. So your compile code, the JavaScript code is emitted to like a file system or just in memory. Right. Any questions so far?
For my side, no. I mean, I'm kind of letting it drip down, and I will ask some questions down the line if I have them.
Sweet. All right, then I will just keep going. This is all like I mean, I don't know how to say it. But this is all in the documentation somewhere. You can find just if you look for the TypeScript compiler API on Google, you probably find something like this.
Right. Yeah. Awesome.
All right. Now we're going to take a little bit deeper into the transform stages. So transform has 3 different stages. Before, which is before the code is compiled. This is like 90% of the transformers is gonna use or is gonna utilize the before transformer. Next, we have the after. So after the code is compiled into JavaScript, you can actually, so this is where if you want to write your own compiler, if you want to implement something in JavaScript after the TypeScript is compiled out to JavaScript, you can use the after transformer. Next is after declarations. So this is after the d.ts is generated. For those who don't know, d.ts is the type declaration file. If you have the declaration flag turned on in your TS config, then a d.ts will be generated. So when I first look at this, I was like, I thought that the declarations will be generated like before JavaScript code is compiled. But when I read more about it, this makes sense because in the before, you can transform the code, you can change the code, and then in the after, which is the JavaScript code, you could still transform the code, the JavaScript code, in the after transformer. So it makes sense for the after declarations, or the type declaration generation is the last step, because it needs to be based on the latest version of the JavaScript code.
Interesting. So the types get generated of what gets compiled and not just what gets written.
Yeah.
Yeah, kind of makes sense, because if you consume this library, you also want to have transformed shape, basically.
Correct. Right.
Awesome.
So those are the transform stages. So to recap, what do we know so far? We know that a transformer is a function that takes in the AST, or representation of our source code, and returns the altered or not AST. So you can have a transformer to be able to read the AST and to grab some information out of the AST without changing the AST, and that's totally fine. That's like some linting tools, right? You can read like these syntax information to output the errors, but you don't have to change the AST. Then we know that the transform stage happens after the parse stage, which means that our transformer will be able to receive the AST from the parser. So that's all we know.
Awesome. Yeah.
Yep. So you keep hearing AST, abstract syntax tree, blah, 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 throughout this from the beginning. What is it? The easiest explanation would be to show an example. So let me share this link in the private chat.
Yeah, I'll share it with the others.
And we're not going to use it. I have some screenshot. If you want to use it, use it. Feel free to explore some TypeScript code. So this is the AST Explorer. You might want to pick the JavaScript if it's not picked already, TypeScript if it's not picked already. And on the left-hand side is a code editor. You can put in some TypeScript code. And on the right-hand side is the abstract syntax tree. So when you put in some code, the TypeScript code on the left-hand side, you see a huge tree that that Bram mentioned at the beginning. And at the top level of that tree is the source file. Usually it is actually the program, but the program contains multiple files, and the transformer will actually read each file. So this AST Explorer is using that source file, because you can only put in code for one file right here. So you can only have one source file, and that's always be the top level for one AST, right, for one single file.
But in your Angular project or NX workspace, whatever, it will look at your tsconfig and bundle it all up, find whatever it can find and what gets imported, and it builds a whole tree of that.
It's actually look for, so in your tsconfig file, it's going to look for that include or the files array or something like that. Basically, what TSC is going to compile, that's what it's going to look for.
Right.
Yep. All right. So in the source file, we only pay attention to the statements, right? Because each of these code right here is a statement. So we only need to look for statements in the source file. So there's that. So right here I have a function called log, and I have a const something else. But when you click on the log, it actually highlights the function declaration. So here the scanner is going to scan, hey, I see the word function, token it, or tokenize it. And then the parser say, oh, I find the function token. I'm going to turn that into a function declaration. So that's this one right here. That is the function. A function declaration will contain the body, the name of the function, and also the parameters of that function. Next, we have the variable statement. Same thing. We have like the const, like a combination of tokens. And then the parser say, oh, I see this combination of tokens. I'm going to turn that into a variable statement. Right. So there's that.
And it's, I mean, you can convert it from left to right and right to left, right?
Correct. That's the point.
Yeah, that's the point. To the extent that the AST has information about on which exact location in the file, which position, start and end, is this thing.
Yep.
Yeah. Okay.
So imagine this is on the left-hand side is the code that the consumers provide. Not provide, but they actually write this code, right? Like your library, if it reads the AST, it actually can just go to the function declaration. And it's just update this function declaration into a different name, a different function name. Or just completely clone, it can clone the whole function declaration into a different function with a different name.
Right, but it could give you a variant of this function. Maybe with
basically
some curry data or something like this.
Yep. So now you can think of a use case of optimization at compilation time, right? Like the consumers don't have to worry about, you don't have to worry about like imitation or something like that. If I see push, I would turn that into the express syntax with the array.
Right.
So that's some use case right there. And each of these declaration statement, each of these is called node. A node is the foundation of the AST. Everything inside of the AST is a node. Source file is a node. Function declaration is a node. Variable statement is a node. So everything extends the node.
Now, is it also correct that inside this function declaration, I have another set of statements?
We're gonna get to that in a bit.
Okay, let's hold off then. Yeah,
yep.
Perfect.
Which brings us to here. So we have a class here instead of a function. So we have a class here. So inside of this class, I declare, not defined yet, right? Declare two properties, foo and bar with the type string and number. And as you said, now inside of the class, so the class is a class declaration node, and it's on the same level of statement. So the class declaration is a statement inside of the source file. But inside of the class declaration, you see there's a members array. So the members array is containing an array of node. Right. That is the children of that parent node. So here I have two property declaration. So one thing to notice here is that you can see that there's class declaration and then there's property declaration. So when you traverse the tree, we can always use some conditional checks. Say, okay, is this a class declaration? Is this a property declaration? You can do different things based on this type, the node type here.
Right. Here. So the reason I just asked it, because I can imagine, let's say you have this class foo and you have a constructor. And inside this constructor, I'm going to say const name equals Brian. Mm-hmm. And then that's another variable statement, right? It's going to be a very similar definition to the top level variable.
Yep. So let's take a look.
Awesome.
So inside of here, you say there's a const name equal Brian, right? And if you click on the constructor, you will see the constructor right here in the same level of the property declaration. So it is a child node of the class foo.
Right, that makes total
sense. And inside
sense.
of that, there's a body, and inside of this body, there's a statement, and we have the variable statement right there.
Awesome. So this block here, the one level up, the block is acting to me similar to the top level source file, where you can just have an array of statements.
Right. This makes sense. Now this all makes sense when we first learn like JavaScript or even like programming language. What is a statement? So inside of a block of code, you have multiple statements. Yep. So there's that. That's the terminologies. If you know about it, then it's easier to traverse this tree. And as you said, Bram, it's very overwhelming if you like expand everything. If you look at a JSON, look at this.
Yeah, yes.
It's very overwhelming, but like with some guidance to point out, hey, this is what you want to look for, then it's easier.
Up until now, the only experience I have, something similar, I think, is opening up a TS file and adding some routes to the router module children, or adding an import to its array. And this is, I think, my only way I touched AST ever. Okay. Basically, open a Nest.js module and register a module there automatically. Sweet. I must say, once you get the hang of it, it's pretty straightforward, and it's all type safe. So you can just let IntelliSense, you can hack your way with it.
Absolutely, yeah. All right, so go back to the slide. So ultimately, our goal is to modify this AST in our favor. Right? So whether to add more code or to gain metadata or information about the code that we're looking at, which is the AST. So you can see that we have tons of information about it, typing, even the spaces and stuff like that for linting tools. That the AST contains all the information you need or all the information it knows about your source code. Right, so next is a demo time, which I'm going to turn over to B-Man or Bram because I want him to drive a demo instead of me, so we can all learn.
Yeah, including me. I'm a newbie. Watch me fail. Okay, awesome. This is gonna be cool. Let's see. I got my screen on here. Okay, perfect. Your screen is gone there. Now, CHAU prepared a repo for me. It will be available after the stream. Links in the description. And then inside here, there's two projects. My TS Transformer. So this is probably the thing that we're going to be working with. And then I see in my test.nest.js here. Can you quickly walk us through what the idea is? And
Yes. So my TS Transformer is our transformer, which again, Bram is right. This is where we're going to work. We're going to write our transformer code. The my Nest.js is our testbed.
right.
Why I choose Nest.js? Because Nest.js CLI has a built-in support for TypeScript plugin. A transformer is a TypeScript plugin. And
okay, interesting.
So that's why I used Nest.js.
Okay, and if you want to do something similar in Angular, it's just a bit more work to wire it all up.
Yeah,
right.
which I will share a repo with the most comprehensive information about setting up like in various bundler for this. Oh, and to be disclaimer, another disclaimer: TypeScript compiler API is experimental, not experimental, but for some reason it's not very mainstream. So it requires some extra setup.
Right, and it's but I think to the same extent, decorators are also still experimental. I've been working with them every day since like 2016. But yeah, okay, awesome. So to set this up, I ran yarn inside this my TS Transformer folder. Yep, that's the one.
Yep. Right. So the next thing is to run yarn in my Nest.js.
Okay, let's do that right here. And you quickly saw, I'm not sure if you did, but I did. It's linking. So this project is linking to the dist folder of this one here, right? So
yep. So I mean, you can show real quick if you go to node modules inside of Nest.js. You will see it's linked.
Node modules here.
And if you look for like my TS transformer,
my TS,
it might not finish install.
Yeah, it's still doing it. Should have run this before.
It's fine. It's okay to show. It's quick enough.
Node modules, and then if we do here my TS transformer, we should see that it indeed is a symlink, a symbolic link to the actual TS transformer top level, and then
yep. My bad. Because I'm using TSDX, so it's a different tool to scaffold TypeScript library. And TSDX doesn't include or doesn't copy the package.json over to the dist folder like NX does.
Right.
That's why I symlinked. I linked the top level of my TS transformer instead of just the dist.
Right. But here in the package.json, it points out to dist index.js and our types. Yep. Awesome.
All right. So the next thing is to do run npm start on the my TS transformer.
Yep.
So it's going to run that TSDX watch, and we can just start working.
Okay, let me open my terminal here and make sure I'm back in my transformer. Okay, and here we can do yarn start. And this should give us a nice, actually I wanted to use this one so I got keyboard access to it. So
Nice.
starting up this one. And then I think it's time to open some source code.
Yep.
Okay.
Again, if you see me look away, that is I'm checking my my code.
Right, your reference implementation.
Yep.
Yeah. Okay, cool. So this is compiling, and then if I check here this index.ts, this is actually the default tsdx
Right.
scaffold, if I'm correct.
Correct. You are correct.
Yeah. For those who don't know, tsdx is a super nice tool to quickly experiment with TypeScript in a clean setup. We're gonna use it right now. Let's go. I think we should be more or less done.
We need to set up something inside index.ts first. So to follow good practice, what I want to do right now is to create a file called beforetransformer.ts.
All right. Go here. Like this.
Yep. And inside of this before transformer, we're going to export a function called before. This function, because we're using Nest.js, the plugin, and Nest.js plugin has a very specific order of arguments. So for this one, the first argument will be the option to the plugin, which for this one we don't have any. So it's just an empty object or any whatever.
Don't let Rob see this from the Angular Discord. Sorry, Rob.
You don't want to make that options. I would put like an underscore.
Yeah, okay. Makes total sense.
No, underscore for the whole parameters.
I'm checking on the screen besides me and not in the actual editor, which is not a great way to code.
And the second argument is the program. So this is the program that TypeScript or that Nest.js is gonna feed into this before transformer, and the program is going to be of type. So you want to import something now. So import type, the curly braces. No, the type and then curly braces.
Sorry. Type, curly braces.
Yep, and from. Let's do the from first. From TS TypeScript slash lib slash TSS server.
Like this?
Yep. And then inside of that curly brace, you can import the program now.
Okay, and program is a class like this or an interface?
It is an interface, I think. I don't remember.
Okay, cool. While this is catching up, I hope we get some real live coding. I'm not sure, some live error correction. It looks like it's about to do that. Yeah, okay, cool. Yeah, perfect.
Cool.
We're there.
Right, so this before is going to return a transformation factory, or transformer factory. So you might want to annotate the type of the return type of this before function. So it's going to be a transformer factory.
There we go.
And the type, yep, and the generics will be a source file.
So it comes from TS Server library?
Yeah, everything will come from TS Server library.
Okay, and then the generic
will be a source file.
File, and that's also going to be from TS Server library. Okay, and
yep.
now
you can do return, and you have the intelligence for you.
Yeah, I mean, I could hack my way around, but
remove that curly brace, right, and then do control space.
Right.
Yep.
So it looks like it wants to return a method with a context. That method will eventually return my transformed source file.
Correct.
Awesome.
So you want to do that context right there. So this context, the transformation context. So this is the context that the compiler is running inside of this context when it's run through your source file. So basically, this context will have information that's gonna mess with that source file, that it is able to alter that source file.
Right. So this is where we do any of our before transformation logic.
Right, and then inside of the context, it actually requires you to return another function. So if you write return and then control space, you will see that.
Right. It will
Right.
have another function.
So that node right there is actually a source file. So as I said, the source file is a node. So you want to rename that to source file to remove, like, to clear up any confusion. So that's source file.
Yeah.
And this require you to return the source file. So you can just return source file and everything will be happy now.
So return source file itself, and then bam, everything seems to be good. Okay,
Yep,
perfect.
yep.
So this is in fact an empty before. We don't do anything with the program. We don't do anything with the context. We just return it as is.
Yep, this is the the skeleton of a before transformer.
Perfect.
Right. The next thing we want to do is on line 4, we want to use the program now. So inside the program, the only thing that we need from the program is the type checker. So we're going to create a const type checker, and it's equals program.get type checker. So you see you have everything that you need right there.
Perfect.
Cool. Now inside of on line 9 or line 11, it doesn't really matter. So you can just grab the context and context that you can see that in here. You can see that you can have that get compiler options. You see that get compiler options. So this returns you that tsconfig that the compiler is running against. So in here, you can get information about what module, what target am I targeting? Is this common JS or is this ES module or something there? So this get compiler options will give you that information.
Cool.
Right. It's my turn to actually look up some code here. Give me 1 second. I don't know if I use C not C. All right, cool. I want to open this. I want to open this code. All right, have this code source before transformer. Cool. Right. So now inside of on line 20 there, instead of return just the source file, we're going to return a function called visit node.
Okay, so return and visit node. Do we get this from somewhere?
Visit node will be from TypeScript server library as well.
As well, okay.
And it takes in the source file. So we pass in that source file, and it will text in a visitor function. So visitor function, will give you the node, which is the source file right now. So just pass in node right there, right? And this visitor function, you can start inside the visitor function. We need to return something else now. So when we say visit node source file, okay, it's going to start traversing the source file. But if you remember from the AST, in the source file, we have 2 statements. And that is actually the child node of the source file. So on line 21, you see that node right there. That is the source file. itself. So on line 24, we can use visit each child. So return visit each child.
Visit each child from your server library.
And then we pass in the node again. And then it will take in another visitor function. And inside of that visitor function, you will get the child node. Right.
Okay,
So now
awesome.
we can start working with this child node. So the first thing I want to test is we have a type checker. So let's try to grab the type of this node. So do const type.
Yep, and then we can do type checker, passing the child node.
Actually, I think the visit each child has a third argument, that is the context. So
is it here in this callback?
No, on line 27.
Okay, context, yep. And
you pass in the context because you have the context up there.
Perfect, yeah. Makes total sense. It's the context that we get here from this transformation context.
Correct.
I'm gonna pass it in here.
And to remove that like wiggly line on that arrow function, let's just return the child node now. There we go. So the type checker, on that type checker, we'll have a function called get type at location.
Get type at location. And we pass in a node, which I guess can be the child node.
Correct. Right now we just do a bunch of console log.
Love it.
So we're gonna we're not gonna log the type as is. We're going to log the source file name, so we know what file we're looking at.
Source file name, perfect.
Yep. We're going to look for we're going to log child node .get text, so we know what statement we're looking at, and we pass in the source file.
Okay. Source file here.
Yep, and we're going to log type checker .type to string.
String, and
we pass in that.
Pass in the type.
Yep, correct. And we're going to console log a bunch of flags. So we can do is import decoration, and we pass in the child node.
These are all methods that we get from the server library. Okay, this is getting nice and consistent.
And then, as you can guess, you can now do is class decoration, is property decoration, is method, is function.
Right. So we can just check here. So, okay, I think this is something that I never really considered. Being there makes total sense, but so I remember when I did this and when I hacked my way through it, I would check if some type is some magical word for me, unknowingly. But there's a lot of things that you can just pass in the node and it will figure out if it complies to a certain contract.
Yep. All right. Now I think we should be ready to just take a look at what this does. Right. Now back to the index.ts, we're going to export this before transformer.
Export from before transformer. Here we go. So we export this one.
Yep. Now the next thing to do.
It builds, so that's good.
Yep. The next thing to do is to go to Nest.js and go to nestcli.json. Right after that, we have the compiler options. And inside this, there's a plugins. And we just use the myTS transformer.
And this works because it's a symlinks package inside node modules.
Right.
Here. It's a symlink, and you can see this little link icon, or at least I can see this. But okay, awesome. So this works.
Now we can actually start the Nest.js app now.
Okay. Start dev mode.
Oh, then no, just start.
Let's start the normal one and start it up here and see what this does. I haven't touched the Nest CLI for about 2 years, I think. Thank you, NX. Okay, so Nest is starting up. I assume it's compiling. I'm not sure.
Your before is actually running right there.
Awesome. Okay, so
let's look at what it does.
Yeah.
So it go through your app.service.ts, right? That's the source file, that file name. And then you log the statement, so that the import statement. And the type is any, right? The import doesn't really have any type. But then you say is import declaration is actually true. It is. This is an import.
Yeah.
Right. And then you can just keep going. So inside of the source file, now it runs again. You remember that visit it child.
Yeah.
So it's run in your app service. There are two statements, so it's going to run twice. You can just look at the source.
Quickly open it up here. So I think the visitor pattern is what they call it.
That is correct.
It's basically a visitor is a method that gets executed on each visit of this thing.
Right.
In this case, a node. So in the source file, we visit each node, and for each child, we're going to execute this code, and this will say, yes, okay, I'm this file name, and this is my type, which in this case is the app service.
Yep.
And it actually, on line 28, we actually print out. Do we print out the source? No, that's.
Yeah, we print out the source file name right there, appservice.ts. And then we print out the actual source code, which is the text of this node. That is the injectable, blah, blah, blah.
Yeah.
Right. So this is like, yeah.
Quickly annotate this just to make it a bit more clear is import and is class. When I save and when I don't have any compilation errors, this should recompile right here. Looks like this is now running, and then I imagine I need to restart this one, right?
Yep, just hit restart with it, or
Yeah, perfect. So it needs to load in the new things, and now we should see a little bit more annotated what is going on here. But,
right.
Yeah. Having this plugins option does make it easy to write these kind of things, right?
Yeah.
Makes it low level. Okay, and then the piece that I was looking at, so the first one all seems pretty clear. I do test here, but it should be text. But this is just basically the whole text. So what I'm interested about here is that it turns out that for this node, which is the class, the decorator comes with it. It's not a separate entity on the list of nodes.
Right. So now can you turn over to like the browser and look at the AST Explorer?
Sure. Let's open that one up. I don't think I got a browser right here. Let me let one open here. Open it up and move it in, and that can go right here.
And right, now just remove everything on the left-hand side, and then pick TypeScript actually instead of Acorn.
What is Acorn even?
I don't even know. Now just do a class with the with a decorator.
Yeah, so I'm gonna, let's say, export class my item just to be original. So this is gonna have stuff, and I'm gonna say injectable.
Yep. Now look at, scroll up into the class decoration. You see that decorators array.
Yes.
So when we write in a decorator and we attach it to the class or any property, that decorator becomes a decorator's array inside the AST of that class instead of a separate thing.
Yeah. Right. So we never analyze a decorator by itself. It's always basically something that comes along with the thing we're inspecting, with the node we're expecting. So in this time, in this case, it's a class, so it will be a class decorator. But if we have property decorator, then inside our property nodes, we will have a decorators array.
Correct.
Awesome. Yeah, that makes total sense.
Right. So that answered that question. Now we can just go back to our project.
So okay, all my questions right now are basically answered. We do loop through every file that we got included. This is another interesting thing to note. So we didn't tell it what files to look at. It's basically starting up Nest, and with this plugin being active, it will run this transformer on every file we do, and it seems to do so in order of the foremost leaf first, which is the service, and then it seems to go back to the thing we actually start up, which is main.ts.
Correct. And if you notice, it's actually just execute on the files inside the source folder. And if you look at the TS config for Nest.js, you know that the source folder is like the include or whatever the TS config point to.
Yeah. So it's not.
If you look at build, can you look at build? So it will exclude everything else and just but the source.
Yeah. Okay. Cool. Perfect.
Cool. So now the next thing, I'm glad that you pointed out. Now it runs over every file. So, but it depends on our use case, on what file do we want that to run, and this is something that the library has to decide. So what I did for my plugin is if you want the transform to run on these files have to end with .model.ts or .interface.ts.
Right.
So we can enforce that. So as you know, now we have that source file. We can grab the source file name, so we can just do a quick check to say if this file name ends with like the requirement that we want.
Yeah, so you can just make condition here and do the very naive way. If this is service.ts, and now we should only get all the stuff outputted from the app service and not from all the rest of the files.
Yep, but here's what I would do, B-Man, is to bring this check on before line 23. We don't even want to visit if this is not it, because we have the source file outside of the visit node.
Right. Yeah. Okay. So the reason I exited here because we have the stuff, but as soon as we have the visitor, and you could do something. If this is not it, just
we return the source file. Or return a node inside that. Return a node, but outside of that is just return a source file without doing anything.
Yeah, and then in your case, this is like, oh, hey, I'm happy to accept model.ts and interfaces.ts, but anything else.
Yep. So that is what the options for this before, right? See that options that we omit. Yep. This is what that is for.
Yeah.
To let the consumers pass in something.
Yeah, that makes total sense. So now you can make your plugin configurable, and you say, hey, next to model and interface, I also want to do .type.ts.
Yep.
And it will take that as well.
Mm-hmm.
Perfect. And now we can see, we run it again in the back, and we see that the only thing that gets printed out is our service.ts. Cool. So basically a way to filter the work you're going to do to make sure you don't have to visit a whole bunch of nodes that you're not going to actually be interested in.
Yep.
Awesome.
Right. So how are we doing on time?
We're in 54 minutes, and we're getting pretty technical already. I love this. We can do at least a half more hour.
Okay. So let's just do it real quick. And we're going to do it really, really simple. So
I won't ask any more questions.
So now let's turn over to my actual plugin. So can you... Yeah, I can share my screen now.
Sure.
Screen. Right.
This should pop in right here. Automapper TypeScript. Go give this one a like if you haven't already. I will share this thing in the captions and in the description below.
Thank you. So here. So if like for people who don't know, I've been working on a project called Automapper TypeScript, and inside of TypeScript, I actually can do a real quick here with the TypeScript playground. Put that up. So let's say I have a class called foo, and I have a class called foo DTO. Inside foo, I have foo type string. I have bar type number. But then I have baz of type, I guess, date, right? Inside my foo DTO, I still have string. I still have bar, but my baz is now a string instead of like a date. But now the problem now is how do I, if I have like an instance of foo, how do I transform it over to foo DTO?
Yeah, and then I think I've done this before manually, and I end up generally with like converter function or normalize function, whatever, and I make a one-off function for this unique case, and I do something like, hey, try to convert this date to a string.
Yep.
That's the imperative way, right? So you have a small little helper method that takes in one, spits out the other.
Right.
But that's not scalable.
Right. Yep. So now you see that, okay, if I wanted to do this in like an automatic way, like foo and bar should be able to map automatically without me having to do anything except for setting up this mapping. But for baz, I'm going to have a function to actually transform a date to a string. But for foo and bar, these should be mapped automatically. But in order to setting up that like auto map metadata, I would need to know that foo and bar is inside of foo, and foo and bar is inside of foo DTO. But now if it just run const foo equals new foo, and I see the logs, if I can see the logs, because I haven't run it, there we go. Never mind. We can just remove this export and run it again. So you can see that the foo, is an empty object. It doesn't have any information about a foo, bar, or baz, let alone the type information.
Right.
So the solution that the AutoMapper library that I work with provide a decorator called AutoMap, and then when you attach AutoMap on foo, and inside the library, I will store this metadata that is, hey, in class foo, I have a foo. In class foo, I have a bar. In class foo, I have a baz. And do the same thing for foo DTO. And then when you set it up, foo to map to foo DTO, I know that foo and bar also appear here. Then I can just map it automatically.
Yeah, if you can see on both sides, they have the same name, same type, you can just pass them along.
Yep. But then now the problem is that the consumers have to use this decorator everywhere in their application, which is a lot of boilerplate. I want a solution that I still be able to get the metadata, but without the consumers having to use the AutoMap decorator. So the solution that I came up with is inside this class is to have a static function. I will give it some really AutoMapper metadata factory, right? And this will return an array of foo, and then I get string, bar, I get string, number, right? And if you log, I'm gonna cancel this one. If you log foo, you will still see the same thing, but if you log console log foo, the class, you see that it has that information.
Yeah.
And like this information, the foo name, the foo property name, and the type, I can totally get it from the AST.
Right, so you can have a transformer that will pick up this file, loop over all the properties you have declared, and get their type, and add them inside a static method.
Yep.
Okay.
And then inside my library, so when the user say, hey, I want to create a map for foo and foo DTO, when they pass in foo, and my transformer already has this information. Inside of my library, I can try because it might not be there, right? I can try calling this function to grab this metadata list.
Yeah.
So that's the idea.
Right. And this is so the goal is to minimize boilerplate and not having to annotate stuff that you can easily look up. And,
correct. And this function is not like visible from the consumer. It will be in the compiled JavaScript code.
Right.
And to simplify this, we will just grab the property name instead of the type. So I want to do that. Right. Full bar is actually bad. This is what I want this function to return.
Right.
So now what I can do is here's the same setup that Dman has, which I will open up in WebStorm instead of VS Code. Let's try running. So it's actually run. So that my TS transformer, and I go to Next.js. That I actually see some log. There we go.
Yeah.
All right. Okay. So now what I do is I go back to my transformer and I say, hey, hey, if source file file name ends with .model.ts. If this is not the case, then I don't want to do anything. And now I have the visit node. So let's have some models, and let's do a foo.model.ts. Right? And inside of here we have a class called foo string bar number. Let's do that. Save. Now what I want to do is, instead of having the visitor here in line, I will create a function called visitor. Right? And this function will take in the node. This is a type node, that, and it will just return the node as well. Hopefully I got this right, because I don't remember.
Looks pretty, right? At least from my point of view. You should be able to pop in the whole method 34 down and
I also need the context, actually. So this visitor function, let's take in the transformation context, and instead of returning no, is actually going to return an inline function, which is
right, which returns node.
Let's just call it visit. Inside this one, I will return a visitor function. Visitor function. Excuse me. Return the visit node visitor context source file. Actually, hold on. This is visit each child. Visit each child right there. So this is inside of the visitor. Okay. This visitor, take in the context, and inside here I have another visitor function, and this one is the type visitor. That, and this one is the node. And ultimately we return a visitor. And here, right there, instead of this function, I will pass in my visitor, and it grab the context. There we go. So now I can do stuff inside of this no thing.
This is just to extract it, right?
Yep. So now I say, hey, if the no is class decoration, and inside of this decoration, I'm not going to do anything but to traverse this node because it is a class, so it has some members inside of it, which is the property decoration. So if, let's say, if the AST hit this class right there, it say, oh, it is a class decoration. So I want to traverse the members of that class. Let me actually increase the font size. I forgot, my bad. Font. Team.
Awesome. Yeah, cool.
All right. Let's not worry about the type checker because we're not going to worry about the type. All right, so we have visit each child, and also here we have this visitor function. We pass in the same visitor function.
Recursively, yeah.
Yep, and we also pass in this context for that. And we just return the node here. Or we can just return this, actually. All right, now, when we say visit each child, we pass this visitor function inside of this. So now it's going to rerun this, and but it's going to go to the next like block. Yeah. So if I'm going to say if is property decoration node, then do something inside of here. I just return the node. So inside the property decoration, now I want to do something. I want to call inspect the node, and I pass in the node, and I also pass in the context factory. So the factory is a node factory, and the node factory, as I said, this context is the context that the compiler is running against. So it has all the information, all the permission to update the source file, to update this AST. So this factory, inside of this factory, it has a bunch of update method. So you can see this, update. So I can update the property decoration and stuff like that to update my class. So this is what I need to actually update my class to have that static function.
So this is in fact the toolkit you have to manipulate source code.
Yep, right. And the inspect node is just a function, and I call it inspect node. It takes in the node, and this is, we know that it is a property decoration. It could be something else too. It could be a getter. So you have like, I think it's getter or property get something like that. I forgot. Get accessor, this one. It could be this. So I do support in my library, I do support property or getter. So if you have a getter, then you have a setter, getter setters, then it's still it will still work. And it takes in the factory. So to a factory, and this is the no factory. And now we can just start doing stuff with this.
Yeah, so now we're at the level where we are going to execute this inspect node method for each of the property we find in our class. So we're going to have like a foo of string and a bar of number going to be visited here.
Yep. And let's also have a metadata map, because we need something like this. And it's going to be a new map. I forgot what I named this one, so let's just see what I named this one. So it's just a string, and it will be a string array. So this map will store all of my, let's say, it will store this like foo, and store as this right there. So we're going to store something like this.
Right, it's going to store a class name with the name of the properties.
Yep, so it's just that, right? Now, inside my metadata map, excuse me. I don't know if I need that inside of. I don't know if I need the factory inside of the inspect node. I might not need to, because factory probably is, yeah, because I don't need it actually, because we were doing some like a minimal example,
Yeah,
so we don't need it.
right. But you might do more stuff at this level if you please.
Right.
Yeah.
Yep. Okay. I got it. Got this.
Bring it on.
So I don't think I need this right at this step. So that first thing, I'm going to grab the parent. So no dot parent, and we know it's a class decoration. So I'm going to just do that, and I do this is the class name. So we got parent dot name dot get text. So this will give us the text, the class name as text. Just do some like quick check here, and we return. So if we don't have the class name, then we're not going to do anything. And we're going to trying to grab the existing metadata. So we got metadata map. We're going to get with the class name. If we find it, if not, we just return an empty
array, probably.
An empty array. Right. The next thing is we try to get the property name of this node. So we get node.name.getText, same thing. And of course, we're going to check. So if property name is not, then we just return. If it has it, then we're going to .set rows. A set, we're going to want to set the class name with the existing metadata
in an array,
and
existing metadata already is an array, right? Destructuring the array.
Yep, that right. With the new property name. So that's what we want for the inspect node. So let's just try console log it. Where should we console log? That's one.
I mean, I think you can just console log the meta map as we created, and we see the 1, 2, 3.
Yep, absolutely.
Properties.
Metadata map. Metadata map.
So I think as of now, this is pretty straightforward. This is just doing some logic, popping it in an array. I know when I build a decorator for the first time for a class, I found it very clumsy, the idea of creating an array and storing stuff. But this is just what happens. This is what it does.
So you can see that right there. So now we have the metadata map. What we want to do is we want to turn this into a function. And I think let's show how to create a function, and then we can wrap this up.
Awesome. Yeah.
So now that is our metadata map, which I have right here. I forgot. So we need to do that. Return node. And then we need to, so now add static function. I want to add to this node, and this is the factory. So we have the function of add static function. We want to add the static function inside of the class decoration. We want to add the static function to the class decoration. So when it gets to line 40, it's actually traversed down to the members. So after it traversed the foo and the bar, then it would just get to here. So at this point, my metadata map should have the information that I need. So now this node, or let's just call this class node, is class decoration, and we need the factory, which is the transformation node factory. That visit each child node ts node. Why is that?
Can you just as class decoration it? Say as class decoration and
Yeah. Yes, that's what I need to do. But visit each child doesn't really return anything, so I don't really need to. But then if that's the case, then I don't think I need to do that.
and they just pass it along by reference, and they just keep on changing whatever gets passed in.
Yep.
Love it. Love JavaScript.
This return the class decoration. What the hell TypeScript is doing? I don't know. You know what? Let's just do this as class decoration. Okay. So now inside of this class node, we have the class node, so we can grab the class name from this class node again with the name, get text. We do a quick check again, return, and then we try to grab the metadata. So this is from metadata map.get the class name, right? And we can check now if metadata or not assist or metadata.length is 0. We just return. We're not going to do anything with that actually. At metadata, now we need the, let's try to grab the return value. We want the return value of this function to be an array, right? So let's do return value. And you know what? This is a great moment to try to see class foo static function name return foo bar. So that's what we want. And let's look at this. What is this? So you can see that what we need is the an array literal expression, right?
With 2 elements.
Yep.
Yeah.
So that's the return value that we need to. We cannot just return an array because the AST doesn't understand an array.
Right. We don't need to return the type, but we need to return the type description.
Yep.
Everything that TypeScript needs to be able to write this type out.
Right. So now inside of the factory, we have the create array literal expression, which is exactly what we need. And then we can pass in the expression, I guess, whatever you want to call it, expression array. So now we have the metadata. We can just map this over to, I guess, let's call this property name. String literal, and we pass in the property name. So that's our return value in the form that the AST understands, which is an array literal expression with 2 elements, which is string literal. This is exactly what we do. Yeah. Array literal expression, we map from our array to an array of string literal.
Now, in this specific case where we check 2 properties, this will always be string, right? Because property name is a string. Is that correct?
Yep. Yep. It would take in a text string. It will also say, "Hey, do you want single quote or double quote?"
Okay. Yeah. Okay. Let's not discuss coding styles, but it should be single quote.
Right. So now we have the return value. Now we can actually start creating this method. So let's just do create method. And let's look what the static method in terms of the AST. So it is a method declaration. So let's start with that. So the factory, again, has a create method declaration. Right now, we can just look at all types of information that this method needs. So the first one is decorators. We don't need any decorators for the static function. We can pass in just undefined for the decorators. But the next one is modifiers. So what is modifiers? Let's take a look again. Modifiers is an array that with a static keyword. So this is what we need. We need to pass in something for the modifiers for this function.
This could also be read-only, public.
Yep, absolutely. So we can do factory, create, modifier, and it takes in what? A static keyword, right? Oh, it takes in a syntax kind. I don't know why it looked for a static keyword here, but we can do syntax kind. And this gives you abstract keyword, any keyword, arrow function, and stuff like that.
So if I want, if I want to do, say, abstract something or private something, I can do this by creating a modifier on this node.
Private identifier or private keyword is right there. So what we want is we want the static keyword, and that is our identifier. Next one is asterisk token. This is not a generator function, so we don't need that asterisk token. What's next? The next one, function name. So function name is an identifier. So we're going to create this identifier. So factory dot create identifier. Let's pass in auto mapper metadata factory. And that's our identifier. Next one is what? Question token. We don't need the question token here, so it's just undefined. Next one is type parameters. We don't have any type parameters for this function. Next one, parameters. We don't have any parameters, but it requires an array, so we have to pass in like an empty array for the parameters. This is the return type. We don't need any return type, so just that. And finally is the body of this function, which is a block. We could just do factory create block. And what this block does, it takes in a set of statements, an array of statements, and the statement that we need is a return statement. Factory.create return statement. It takes in what? An expression. Guess what? Our return value is the expression.
Love it. Awesome.
And then this one is multi-line because I wanted to have like multi-line if I have like more information here. Right.
Now, I guess some people would maybe check this and think this is just like writing code, but with a lot more steps.
Right.
Writing AST, and this is like, but because I think it's kind of nice if you scroll back to if you move back to the editor. This is kind of this is just writing out a static method. This is, in essence, automatically saying static auto mapper blah blah is a new function, and I'm going to return this thing, and you're even typing it. So it's super interesting. Programmatically programming, in a senst.
Yep. And now the last thing to do is we have this method in a form of the AST. What we need to do. So if we look at this, so let's make this a little bit into what we want, right? So you can see that this method declaration belongs to the members array. So we know that we need to update this class node, but specifically the members array. So we do return a factory update as declaration right there. Now, again, we have to pass in a bunch of things because you might update decorators and stuff like that. So we pass in this class node as is.
Which is the thing we're working with.
Decorators. We're not gonna like remove your decorators. Class node modifiers. Let's say we're not gonna remove your abstract keyword. We're not gonna remove all that. Same thing. The name. We're not gonna change names. Again, we're not gonna change your type parameters. Type parameters. Is this class node? Oh,
class node.
Class node. And we're not going to change anything from your heritage clause. Heritage clause is like implement or extends. Then the last thing is what? Is the members. So this is what we want to update. So we're going to spread the current members, and we add our method on at the end.
Lovely, and TypeScript all of a sudden is super happy.
Yep. So now,
awesome.
Let's see. We have this as static function. Actually, this return on the update node, so we can just return it right there. Right. So now let's save and see if it actually works. right?
So it's going to be
Wait for
recompiling
change.
here.
It compiled successfully.
Looks like that works.
I'm going to restart my nest. We're not going to see any log here because we don't log anything as of this moment.
Can we peek inside the dist of Nest to see if we find the
Yep.
automapper reference?
Yep, this is what we're going to do, and that it is.
Awesome. Cool. So yeah, okay. So we just compiled the before transformer, and because it's loaded in the plugin, it went through all the things. It found our foo.model.ts. It ran its logic. It checked which property it had. It created a new static method that returns an array of string, and this gets printed out in the step that comes after the transformation step.
Right.
Awesome, super cool. I think it's the best explanation I ever had with about compilers and how to do these kind of things. I'm ignorant in this kind of stuff. It's totally new for me, this area. I do have some experience with decorators. It's the only thing I can really relate this to. Why you want to do this? This is also what you use it mostly for.
Yeah.
So interestingly enough, about a year ago, when I didn't have a YouTube channel, or I think we just got to know each other through Twitters, I actually popped up a tweet because I wanted somebody to explain me how decorators work and how to write them myself. And this is exactly the thing I needed to learn, combined with your other two. So this is a great explanation. I actually asked our chat if there was any questions, but there seem to be none at this point.
I guess this is probably a little bit technical. So yeah, I hope people learn something today. I hope you guys can leverage something that we talked about today to build something for yourself, because I think this is actually a pretty helpful tool to have.
Yeah. The way I see this being useful in my use case, I write a lot of repetitive code, and I see this as a way to basically get rid of a bunch of boilerplate there. And the other thing where I see usefulness myself is in some sort of way generate code, so I don't have to write it myself. Just have some logic and
absolutely, yep.
Yeah.
And I mean, like, now you know that you need to like play with these conditional check function and also the factory, so you know what actually you want to do, and go back and forth the ASD Explorer, that you know, oh, I need to create a method declaration, I need a modifier, I need a block, blah blah blah. So it's all there, just you know where to look.
Very cool, awesome. So I think this is a great introduction. Do you have any more to share things about this? I think ASD Explorer as a resource is amazing for people diving into this. Any other tips, tricks, things to check out?
This one. So this is a repo for a library called tsnemoff. So if you are a C# developer, you probably know the nemoff function in C#. That is a compilation time function that gives you the name of whatever expression that you pass in.
Right.
So this tsnemoff, this is the coolest thing, that you can grab the name of your interface at runtime. Right. So this is using the before transformer.
But at runtime of the transformer.
Correct. So you can see that right here. Name of my interface is actually give you my interface. And as you know, interface is gone at runtime.
Yeah.
But for some reason, it will be able to grab it.
Very cool. So this is useful if you want to keep this stuff, like, let's say, instead of doing an array of string, we want to get more metadata. We can use this name of function to capture these kind of things.
Yep.
And maybe render them out in documentation or whatever we want to use it for.
Yep. And I want to bring up this. Let's see. This is the README, because this guy has, to be honest with you, right there, common source. I remember there's like a bunch of setup. This name of TypeScript compiler. Yeah, setup right here. So this guy show you how to set up with Webpack, Go, just custom, blah blah blah. So
Right.
you know how to set up the transformers to work.
Awesome. Awesome. Ciao, thanks so much for sharing this. Is there anything else you want us to know? Or no, it looks like you stopped sharing screen.
Oh yeah. I don't have any right now,
Okay,
and
awesome.
that's all.
Awesome. Okay, cool. Very cool. Thank you so much for being here. It was a blast having you on again. We should definitely do this further, but I have no doubt that we will organize something soon.
Yep.
Here on this channel is going to be more compiler stuff. I'm working on a session with Alex from the Angular team, and we're going to look at the NGCC Angular compiler. And maybe I can trick Joost into coming here as well, because I would love to understand how he makes optimization to TypeScript that we all benefit from. And this is going to be way above my head, but I try to follow along. And yeah, for me, it's been super motivating seeing this kind of stuff. It's a privilege to have the space where people like Ciao come on and explain me stuff I've been wondering for years. So thanks a lot, everybody. Thanks for the support. Thanks for being here, and I hope to see you very soon. Bye bye.
All right, thank you. Bye bye.